Okay, this is the last question of the November 2020 paper 2 analytical geometry question in the exam. And let's just take a look at it. It says, if another circle has a center of -2 and 5 and a different radius k, but this circle touches the circle centered at M, figure out how big k is. This one's tricky. The first time I tried it, I went and did the circle that M goes through, the small circle, and did the question. That wasn't very good. So this is a story. Now, what I do is here's the circle centered at M. Now there's another circle with a center of -2 and 5. So I put it up here. I just want a picture of what must be going on. Okay, there's a circle that goes around this, a small circle that will be just big enough to touch right there. So that's the situation we're talking about. We would like to just um, go out the radius of this circle. Imagine it getting bigger and bigger till it just touches there, right there. Or we could go for a circle that's way bigger, that goes out this way, bigger and bigger and bigger and bigger. See this big circle around here. So there's two answers where it can touch. It, there's a small circle where you just go out this amount, we'll call it K1, from here to here. And then there's one where you go out this whole distance here, and that would be the radius of the bigger circle. Okay, well, this is how I did it. The first thing you have to figure out in this picture, well, from -3 and 4 to -2 and 5 is a distance. I put that in the distance formula, put it in the distance formula, MB, and it gives you √2. Now, I can use this both times. Now, if I'm going for just the small circle with this red line here, I start at this center and I would go out and it would get this big. Okay, how big is that? Well, there's a distance of 8. That's the distance, the radius of the circle centered at M. And then I just subtract √2. Well, there it is, 6.6 units. I did that on my calculator. I got all this, 6,6 units to the nearest tenth. But look, what about this one where we're making it bigger? Well, there's your √8, or there's 8 plus the √2. That's 9.4 units. So there's two circles. There's a big circle, this big one out here that you can just, this circle would, if you made that circle, it would touch just once. It would touch the circle that's centered at M. And the little circle, if we go out here, touches the circle centered at M over here. And one is going to be 8 minus the √2 part here, and the other one's going to be 8 plus the √2 part. That's a pretty tricky question. I read it a little bit wrong, and I was careless, and I did it in a different way. Here's how they explain it in the memo. They've got a little circle going out to touch the circle centered at M, and they've got a big circle going out like that. And showing how it just touches in one place, but they've got the same units. I went and did the little circle that M goes through the first time, and I did a problem like that, and it's all right for a different question that touches the circle centered at the origin. Whoops, that's why I did it the first time, and then I got it right. I looked at it more carefully. Okay, well that's it for analytical geometry in the 2020 paper.